Hello all, welcome back. In this video, we'll be discussing about red-black tree. Generally, a red-black tree is called as a self-balancing binary search tree. That is, first it follows the properties of binary search tree. And what is the property of binary search tree? So the leftmost value should be less than the root node value, and the rightmost value should be greater than the root node value. This is the property of binary search tree, and that is how the red-black tree also consists, like containing the values. And this is a balancing binary search tree, and this is called as a self-balancing binary search tree. That is, whenever a tree is unbalanced, then it automatically performs some operations to balance that tree. Coming to the properties of red-black tree. So there are 5 properties, important properties of red-black tree. Starting from the first property, that is, each and every node of the red-black tree should be colored either in the red color or in the black color. This is the first property. And the second property is always root node should be in the black color. And then the third property is no two adjacent nodes should be in red color. That is, there shouldn't be any consecutive red nodes in a tree. That is the third property. And the fourth property, so when you traverse from the root node to leaf, in all the paths, okay, the number of black nodes should be equal. Okay, if you take one path and if the number of black nodes are 2, then the same should be in the remaining paths as well. So all the paths from the root to leaf should have the equal number of black nodes. And the last property is always the newly inserted node should be in red color. Okay, except root node, whatever the node you are inserting newly into the tree, that node should be in red color only. So these are all the 5 important properties of red-black tree. Now we'll see an example and what are all the operations that we can perform in the red-black tree. So here are some examples for red-black tree, and you can see the first example, we should check whether all the properties are satisfied. So what is the first property? What is the first property we have seen? Every node should be colored either red or black. So in this example also, we can see all the nodes are colored in black color. And what is the second property? Root node should always be black in color. So the root node is black in color. And the third property is no two adjacent red nodes. So in this tree, you can see there are only black nodes. So there is no red nodes at all. So this can also be fine. Okay, and what is the next property? All the path from the root to leaf should have equal number of black nodes. So if you check from here, this is our root node, okay, and these are all the leaf nodes. If you take this path, there are 2 black nodes. In the same way, if you take this path, here also we have 2 black nodes. So from root to leaves, in all the paths, we have equal number of black nodes. The same properties can be checked for this tree also. So here root node is black in color, and when we check the property that number of black nodes, yes, in this path we have 1 black node, and in this path also we have 1 black node. And you can see all the nodes are colored either in black color or in the red color. And one more property, there are no 2 adjacent red nodes, right? Because here you can see we have red node and black node. Here also we have black node and red node. There are no 2 consecutive red nodes in any of the path. So this is what the important property that we should make sure. Okay, coming to this one. So here this is also an example, but you can see this is not a red-black tree. Why? Because see, this property is not violating. That is, the root node is black in color and all the nodes are colored somewhere in black or in red. But the fourth property, that is the number of black nodes from root to leaf, you can check here in this path we have 3 black nodes, right? And if you check with this path, okay, you can see in this path I just added a new red node. And if you check this path, we have only 1 black node, and in this path we have 3 black nodes. So this is not satisfying the property. So you cannot say that this tree is a black tree. The same applies here. In this path, you can see we have what? Two black nodes in this path. And what if I have one more node like this? Okay, if I have one more node like this, and here you can check in this path we don't have 2 black nodes where we have only 1 black node. So this is not satisfying the property of red-black trees. Okay, likewise you need to check whether the tree is satisfying all the properties or not. Then what are all the operations we can perform with red-black tree? So the 2 major operations that we do is insertion and deletion. So we'll see how insertion happens in red-black tree. And for performing insertion operation, we need to follow these steps. So what is the first step? You have to follow binary search tree to perform insertion. So as I already mentioned, what is the property of binary search tree? Binary search tree property is all left hand side node value should be lesser than the root node value, and all the right hand side node value should be greater than the root node value. This is the property of binary search tree. So whenever we are performing insertion operation, we should follow the binary search tree property first. And then once you start inserted, okay, so I already mentioned the, like for insertion, what property we need to follow is always a newly inserted node should be red in color. So whenever you are doing insertion, you need to check whether you are getting 2 consecutive red nodes in a path or not. Okay, that is what you need to check when you are performing insertion operation. So if we if the property is violated, that is we obtain 2 consecutive red nodes in a single path, then at that time we can say that the tree is unbalanced. It is violating the property, so we can say the tree is unbalanced. So when the tree becomes unbalanced in red black tree, if we obtain the case like there are 2 continuous red nodes in a path, okay, 2 continuous red nodes in a path, then that property is violated. We can call that red black tree is an unbalanced tree. So for balancing that tree, what we can do is we can perform 2 operations. One is rotation and the other one is recoloring. So here if you take these 2 operations, when we have to apply rotation and when we need to do recoloring is completely dependent on the color of uncle node. Okay, here what is called as uncle node? Uncle node is nothing but the node which is the sibling of the parent node. So the sibling of parent node is called as the uncle node here. Okay, so based on the color of uncle node, we are going to perform either rotation operation or recoloring. Okay, so when rotation will happen and when recoloring is happening. That is, if uncle node color is red, okay, then we need to perform recoloring. And where you are going to perform recoloring, you need to recolor parent node, grandparent node and uncle node. Okay, this is for red color. What if uncle node is black color, or if there is no uncle node at all? Okay, if there is no uncle node means we can say the uncle node is null. Even for null node also we can assign the color of the null node is black. Okay, so if uncle node is black in color, or if there is no uncle, if the uncle is null, okay, in that case also it is black only. So if in that case, okay, what we need to do is we need to perform rotations. And what rotation? As we already know the AVL rotations, 4 rotations, right? A single rotation, 2 rotation, and double rotations, 2 rotations. So that rotation we are going to perform, and after performing the rotation again we need to do recoloring. Okay, so these are the steps we need to follow when you're performing insertion. Now we'll see an example how to do insertion and how we are going to balance the unbalanced red black tree. Here is an example where we are going to insert all these values into an empty red black tree. Okay, so what is the first property? When we are performing insertion, we need to follow binary search tree condition. Okay, so that should be followed first. And second thing, whatever the node you're newly inserting, that should be in red color except the root node, because the property of root node is it should always be in black color. So now in the empty tree, I'm going to insert all these values starting with this value 8. Okay, so if I want to insert 8, in the first step I'm inserting 8, and now since this is empty tree, 8 is my root node. So since 8 is root node, this is in black in color. Okay, I'm keeping 8 as a black node. Right, this is what the first step. And coming to the second step. Second step is I need to insert 18. So when I am inserting 18, first I need to follow the binary search tree property, which means compare this value with the root node. So 18 is greater than 8. So it should come to the right hand side. So I need to insert this 18 to the right of 8. And one more condition, this is a newly inserted node. So if I'm inserting it newly, then it should be red in color. So in the second step, as usual, I'm keeping 8. Okay, and after that, I'm going to insert 18, and which should be red in color. Okay, so this is my second step. And what is the third step? Third step, we have the value 5. Again, compare the value 5 with root node. So this value is lesser than the root node value. If it is less than, obviously it should be placed at the left hand side. And once you start inserting it, left hand side, okay, it should be 5, and this is a new node, so it should be red in color. New node should be red in color. Okay, after inserting 5, this will be our tree. And what is the next value? It is 15. Again, compare 15 from 8. Start comparison from 8. 15 is greater than 8. So it should be at the right of 8. Again, in right of 8, we already have 18. So compare 15 with 18. 15 is lesser than 18. So it should be placed at the left of 18. And when you place 15, how will it get placed? So here 5 already and here 18 already. Now 15 will get placed at the left of 18. If you observe carefully, here this tree is violating the property, that is you obtain 2 consecutive red nodes here. So what happened? We are getting 2 consecutive red nodes. So this is violating the property. Now the tree is unbalanced. So we need to balance this tree. So what you will do for balancing? You need to check the uncle node color. So this is my new node inserted. And for this new node, what is the uncle node? Uncle node is sibling of parent. What is the parent of 15? 18 is a parent of 15. And what is a sibling of 18? That is 5. Now 5 is the uncle node for 15. So what is the color of this uncle node? It is red in color. So what is the property? If the uncle node is red in color, then we need to perform recoloring. So where do you perform recoloring? Okay, so recoloring can be done on uncle node, parent node and grandparent node. Okay, so when your uncle node is, when the uncle node of 15 is red in color, then we need to perform recoloring, and recoloring happens on uncle node, parent node and grandparent. See, if you look at here, the grandparent is the root node and it is black in color. If I try to change the color of this grandparent which is at root, okay, I shouldn't do that because always root node should be black in color. So when the grandparent is the root node, then don't change the color of the grandparent. Okay, keep as it is. If it is not the root node, then as usual you can apply and you can recolor it, right? So now after performing recoloring, how my tree gets changed? Okay, so I'm not going to change the color of my grandparent since it is a root node. Keep as it is. Then now uncle node is red in color. If I recolor it, then it will become black color. Parent node is also red in color. If I do recoloring, then it will become black color again. And don't change the color of child node color should be same as it is. Don't change this color. Okay, but only you are doing recoloring on what? Uncle node, parent node and grandparent. Grandparent is root node, so I'm not changing the color of grandparent here because it is root node. Right? Now, what is the next value we need to insert? So the next value we need to insert is 17. So where 17 will get placed? Compare it from the root node. 17 is greater than 8. So move to right hand side. Again compare it with 18. 17 is lesser than 18. Then move towards left. Again compare 17 with 15. 17 is greater than 15. So move towards right side. So now place the value 17 to the right of 15. So if you insert 17, how it will be inserted? 8 and here it is 5. Here it is 18. And then this side it is 15 already in red. And this side, sorry, not this side, left of 15 and right of 15, that is 17. Now 17 will be placed here, okay, which is also red in color. Right, now again if you check, it is violating the property because 2 consecutive reds here. Okay, and now when you get this 2 consecutive red, you need to check with the uncle node of this newly inserted node. Newly inserted node is 17. What is the uncle node? There is no uncle node. You can see parent of 17 is 15 and there is no sibling for 15. If there is no uncle node, we are considering it as null node, and null node is black in color. So it means it is stating that the uncle is black here. What if the uncle is black? So what we will do? We will do rotations. Okay, after performing rotation, again we will apply recolor. Okay, so first we will see rotation. How do we perform rotation? Okay, and you can see the structure of this subtree. So what is the structure of the subtree? Left, right. So when the structure of the subtree is left, right, then you need to apply left, right rotation. Okay, here we are applying what? Left, right rotation. So once you apply left, right rotation, that is LR rotation. Okay, so what will be the tree? How the tree will become? So 8 as usual root node. Okay, there is no change in 8, and 5 will be in the left hand side. Now we'll be taking only these 3 nodes. If we apply double rotation, that is LR rotation, so the tree will be like 17 becomes the root node. Okay, 15 and 18 becomes the child of 17. So 17 becomes a root node. Okay, and 15 will be the left child and 18 will be the right child of 17. Okay, this is what we are doing with LR rotation. If you apply LR rotation, this will be the final tree structure, and you can see the color of the node. So what I have done, I just swapped the color of 17 and 18. Okay, so what I have done here, I have swapped the color of this node with this node. When you are performing double rotation, at that time you should swap the color of child node with grandparent. But if you are doing like a single rotation, say LL rotation or RR rotation, in that case where you will swap the color should be swapped between parent node and the grandparent node. Okay, if it is double rotation, remember that you need to swap colors of child node and grandparent node. That is what I have done here. But when you are having single rotation, when you are performing single rotation, at that point you need to swap the colors of nodes, that is parent and grandparent. Okay, so this is what after rotation and recoloring. Now I inserted 17 and there is no problem with this insertion. Okay, now the tree is balanced. After doing this, the tree is balanced now. Now what is the next value I need to insert? I need to insert 25. So where 25 will get inserted? Again compare it with the root 8. So 25 is greater, go to right side. Compare it with 17. Again 25 is greater, go to right side. Again compare it with 18. 25 is greater, so move to right side. Right side it's empty, so you can place 25 to the right of 18. So if you place 25, how the tree will become? So here left side 5, 17, and in the left hand side it is 15, and right hand side 18. Now 25 will get placed here. Okay, here also it is violating the property. If you observe carefully, we have two consecutive red nodes. So again, check for the uncle node of 25. What is the uncle node of 25? That is 15. What is the color of this uncle node? It is red in color. If it is red in color, just to do recoloring. And where you have to apply recoloring? On the parent node, on the uncle node and the grandparent. And you can see here this grandparent is not the root node. Okay, if it is not the root node, what we can do? We can apply the recoloring on grandparent also. If it is a root node and black in color already, don't change it. If it is not a root node, we can change the color. So now I am applying recoloring here. If I apply recoloring, 8 will be in black as it is and 5 will be in black as it is. Now coming to 17, 17 is already black in color. So now this will become red in color. And coming to 15 and 18, those are all already in red color. Now after doing color change, this will become black. Okay, so in right hand side we have 25. We are not going to change the color of the child that is newly inserted. No, that will be as it is. Right? Now we'll go for the next value. So what is the next value we need to insert? The next value we have here is 40. So we need to insert 40. Where do we insert 40 now? Again compare it from the root node. 40 is greater than 8, go to right. 40 is greater than 17, go to right. 40 is greater than 18, go to right. 40 is greater than 25, again go to right and place it in right of 25. So now if you start inserting 8, left of 8 is 5 and right of 8 is 17. Then left of 17 is 15. Right of 17 is 18. Again right of 18 is 25 which is red in color. Okay, so now we are going to place 40 which is again right of 25 which is also red in color because newly inserted node should be red in color. So 40 is also red in color. Now you can see it is violating the property, two consecutive red nodes. In that case, what you will do? Again check for the uncle node. What is the uncle node of 40? There is no uncle node. There is no uncle at all. If there is no uncle, we will consider it as black color. So what we will do when the uncle is black? We will perform rotations and then recoloring. Okay, so what type rotation, like what rotation we can perform here? This is my child node and there is no uncle here, so I'm going to consider these three nodes. In these three nodes you can see it is right skewed. If it is right skewed, I can perform single rotation, that is single left rotation. If it is right skewed, apply single left rotation. If the tree is left skewed, then apply single right rotation. Now I'm going to apply single rotation. That is what rotation? LL rotation. Okay, left rotation, because the tree is right skewed. So if I apply single left rotation, then what will be my tree structure? That we will see. So now we'll draw these tree as it is, whatever we have. 15. Okay, now we are going to apply rotation on these three nodes, right? So when you apply single rotation, 25 becomes the root node, 18 will be the left of 25 and 40 will be the right of 25. After rotation, this is our tree. Okay, but coming to color change, I told you already, when you are performing double rotation, color change should be on parent and child, grandparent and child node. When you are performing single rotation, color change should be on grandparent and parent node. Now what is parent node? 25. 25 is in red color. Now change that 25 red color to black color. So now in 17, after 17 we will get 25 which will be in black color. What is the right child of 25, which is 40? This is already in red, so maintain as it is. Coming to left child, this is the grandparent, right? 18 is the grandparent of 25. Now this becomes the left child of 25 and we need to swap this color, like recolor it from black to red. Okay, so this is what our tree structure after performing rotation and recoloring. If you check after this, if you check the property, that is black node property, in this path we'll be having two black nodes. In this path also we have two black nodes. In this path also we have two black nodes, and this path also we have two black nodes. So the number of black nodes is equal in each and every path of the tree starting from root to leaf, and there are no two consecutive root nodes as well. Okay, so then the tree is balanced now. This is after inserting the value 40. Now what is the next value we have? Last value, that is 80. What will happen if we try to insert 80 into this tree? Okay, where we will insert 80? Again start comparing it from root node. 80 is greater than 8, so move towards right. Again compare with 17. 80 is greater than 17, move to right. Again 80 is greater than 25, move to right. 80 is greater than 40, so insert it to the right of 40. Now I placed 80 here. 80 get inserted here. If you check here, again it is violating the property. That is two consecutive red nodes in this path. So what shall we do? Check the color of the uncle. Now color of uncle is red in color. If it is red in color, what we will do? We will perform recoloring. And where do we apply recolor? Apply recolor on parent, grandparent and uncle. Okay, so if I apply recoloring on these nodes, so what will be the tree structure? See, I'm going to perform recoloring on this. Now, let 8 as it is, let 8 be as it is, and left of 8 is 5, which is black, and right side it is 17, which is red, and again coming to left of 17 is 15, that is black. Now I need to change colors of this node and this node, right? So 80 will be as it is. It isn't red in color, but we need to recolor these three only. Now this is black. So if I am doing recoloring, then this black node 25 will become what? Red in color 25. Okay, coming to 18, 18 is in black, sorry, red. So now I need to change it to black. Again, 40 is also in red. So I'm going to change it to black. 80, 80 is in red. So keep as it is 80. Okay, so I just did recoloring because the uncle node is red in color. And if you look at this tree, okay, the resultant tree, after doing recoloring, again it is violating the property because two red consecutive reds, right? So again we are getting two consecutive red nodes. So this is violating the property. Again, what you need to do now, repeat the same process. So considering this node as our child node now, okay, check for the uncle of this node. So what will be the uncle of this node? What is the parent of 25? It is 17. What is the sibling of 17? That is 5. So what would be the uncle node for 25? It is 5. What is the color of uncle node? Which is again black. Okay, if it is black color, we need to perform rotation and recoloring. So where you will perform rotation? Just consider these three nodes only. Okay, take these three nodes because this is your child node. Considering this from this child node, you're going to take these three nodes and you are applying rotation here. And this is the right skewed structure. It is in right skewed structure. If it is right skewed, apply what? Single left rotation. So if you apply single left rotation, what would be the tree structure? Okay, so 8 will become the left child of 17. Then 25 remains as it is, right child of 17, and 17 becomes the root node. So when 17 becomes a root node, 17 will be in the black color. Also one more thing I told, that when you are performing single rotation, where you need to perform recoloring? On the parent node and grandparent. So grandparent is 8, which is black in color, that will turn into red, and coming to 17 is parent, parent is red in color, and now that becomes the black. Okay, so 25 will be in red as it is, no need in 25, sorry, no change in 25. Again coming to 8, 8 becomes the leftmost value of 17, left side value of 17, and from black it changed to red color. Okay, now we'll place the remaining nodes. Okay, and coming to 5, 5 as it is left of 8, so place 5 as it is, right? And then coming to this 25, we have left of 25 is 18, right of 25 is 40, and what is the right of 40? That is 80. Okay, and what is still remaining? 15. We need to place this 15. So where we will place? For this, again you need to check, it is already in the left of 17. So check from 17. 17 left hand side. 17 left hand side, it is already 8. So compare this value 15 with 8. 15 is greater than 8. So 15 should be placed towards the right of 8. So here we will place 15, which is black in color. Okay, so now after performing rotation and recoloring, this will be our final tree. And if you check this tree, this satisfies all the properties of red black tree. That is, the root node is black in color, and there are no consecutive red nodes. And if you check number of black nodes in each and every path, that is equal. That is 2 black nodes in each and every path, right? So this is what the red black tree insertion and its properties.